Hello, today I would like to test this hair dryer and I would like to see if it is as it is supposed to be. So here's the box and it says that it is 3000 watts, 3 kilowatts and 60 degrees Celsius, which I assume is the air output. I have this setup. I have this DC motor with a fan which serves as a very crude way to measure speed of wind. I have this thermocouple covered in tin foil so that I can measure the temperature of the air. I have a current clamp around one of the wires of the hairdryer so I can see how much energy it consumes, and I have a microphone with a 3D graph and an octave preview. Here we have the setup. We can see the 3D graph, the octave preview recorder of the wind meter, recorder of the temperature, and recorder of the current clamp. So now I'm going to turn on the hairdryer at different fan settings and temperature settings, and then we will analyze the results. Okay, now that we have recorded everything, we go to analyze and we can see everything. So first we can see the sounds for the easiest graph. It's noisy with the highest peak in frequency is at about 292 hertz, and then there's lots of other frequencies as you can see here. And changing the fan speed from 1 to 2 greatly increases the amount of noise, mostly on the 292 hertz frequency. Before it's very small, then it becomes much taller. The octave preview basically doesn't tell us anything. I do not know why, but it doesn't really give us much information. It's the fan with the DC motor. We can see that there's roughly twice the speed of wind at double the fan setting. For the temperature, we reach about 39 degrees Celsius. I probably didn't hold it long enough or the right way, because when I tested it earlier, it reached 60 Celsius. And the very interesting part is the current, as it makes basically no sense to me. So fan speed 1 with the heating element at 0, we have minus 2.7 amps, about 200 watts. So probably the heating element is on even when the heat is set to 0. So that's interesting. Here we see it's basically bigger, so the heating element also uses only half rate, which is really weird. I have no idea why you would like to rectify with a single diode rectifier the input to a heating element, because not only does it not make sense to rectify a current going into a heating element, but it also doesn't make sense to use a single diode rectifier. It's only used for very low power, and this isn't very low power. Again, I do not know what is the case. If we go into speed 2, we can see that it now uses the full sine wave, and then it just uses more sine wave. So this is the maximum consumption, 4.88 amps, and the 3 kilowatts that were written on the box, that's the maximum consumption. If you look at the max I got was 4.44 and 88, and we multiply by the average voltage here, which is 225 volts, and you get about 1.098 kilowatts, which is almost a third of what was written on the box. But I assume that that's the maximum energy consumption. So for example, maybe since here it is hotter than in other places, it uses more power. However, I find this strange, since I would assume that to be just like a A switch that does on off the heating element when the temperature goes over a certain temperature. So the fact that it regulates the percentage of power of the heating element seems very weird to me. Also because it is a $10 hairdryer, €10. It is not an expensive hairdryer, so I do not expect it to do like PMW with modulation. One thing I should say is that this fan with the DC motor is quite an imprecise way of measuring speed, and what I do believe is that double the speed of wind would cause double the voltage. I'm not sure, so it's possible that speed 2 has like 3 times the velocity of speed 1, and simply my measurement is not linear. But unfortunately, I cannot calibrate it because I do not have a source of a known speed of air. If I had a 10 meter per second air supply and a 20 meter per second, then maybe a 5 meter per second, then I would be able to adjust this and basically convert from volts to meters per second. So I do not know what the speed of the fan is. That's basically all. We have seen the volume emitted, the current measured, and temperature and sort of wind speed. Bye.